Hello students, good evening everyone. I hope all are doing well. Anyway, welcome back all of you to the Infinity Learn JEE YouTube channel. This is me Surya, your chemistry faculty from Infinity Learn. Okay, I believe I am perfectly audible and visible to each and everyone. If anyone is watching this particular live, please give me a hi. Hi Adar, good evening. Okay, how was the exams? Okay, now let us quickly start with the topic. Yeah, great. It was good, right? Okay, fine. So here in this particular session, we are going to discuss one of the important chapter from the organic chemistry topic, that is hydrocarbons. This is the last topic or the last chapter from your grade 11 chemistry topic, right? So this is very important. I need your complete attention in this particular session. So we will be discussing alkenes and alkenes detailed in the different classes. So here we are focusing to we have discussed about the chemical properties, right? Nomenclature as well as isomerism of the alkenes detailing. So let us quickly start it. What do you mean by hydrocarbons? What are the main components present in the case of an hydrocarbons? These are organic compounds, right? Okay, I was planning to take this particular chapter in 3 or 4 lectures, right? We are starting. For alkene, there will be 2 lectures. For alkene, again 2 lectures. Then for alkene, then aromatic hydrocarbons. Total part 7. 7 parts will be there. We will practice some questions also based on this particular topic after each session. Right? Hi Sumit, good evening. Okay. I have a question for you. What do you mean by hydrocarbons? I have a question for you. What do you mean by hydrocarbons? Hi Saumik. Okay, hydro means hydrogen, carbon means carbon, right? So the organic compounds that contain carbon and hydrogen is commonly known as hydrocarbon. So let us go to the classification of hydrocarbon. First of all, I am dividing this hydrocarbon into 2 parts, right? So first one I will call it as aliphatic hydrocarbons. Then it will be cyclic hydrocarbons, right? So what do you mean by aliphatic hydrocarbons? Saumik, I can understand Hindi, but I am not that much comfortable with the Hindi. Okay, I will try to learn Hindi. Okay, what do you mean by aliphatic hydrocarbons? The hydrocarbons in which only the straight chain carbons, right? There will not be any cyclic structure or any benzene-like rings, right? Okay, straight chain hydrocarbons are commonly known as aliphatic hydrocarbons. So in case of cyclic, just like the name, cyclic means there will be containing cyclic compounds, right? Just like aromatic or benzenes. Let us see the classification. So here, aliphatic I can again divide into 2 parts. What are they? Any idea? Okay, saturated and unsaturated, right? So depending upon the carbon-carbon bond, we can define these aliphatic hydrocarbons into 2 types. One is saturated hydrocarbons, right? Saturated means these particular hydrocarbons contain only carbon-carbon single bond or carbon-hydrogen single bond. So in case of unsaturated, there will be either carbon-carbon double bond or carbon-carbon triple bond happens, right? So based on that particular elements, we can classify them as called as alkane, right? In unsaturated case, it will be alkenes if it is containing double bond. Then again it will be classified into alkynes if it is containing triple bond, right? So in cyclic cases, we will be focusing here about the aromatic carbons, aromatic hydrocarbons, which means that there is a broad classification. In general, we can say that benzene is an aromatic compound, right? So here we will be discussing about the aromatic hydrocarbons. So in this particular chapter, the hydrocarbons, we will be focusing these 4 different topics, right? Alkenes, alkenes, alkynes and aromatic hydrocarbons. Clear? So let us start with the first compound, that is the alkanes, right? So as we already know, it is the aliphatic compound, right? Aliphatic means straight chain compounds. There is no any cyclic compounds. Saturated, that means it contains only single bond, right? Carbon-carbon single bond or carbon-hydrogen single bond. So in general, these aliphatic saturated hydrocarbons are known as alkenes, or one more name is known as paraffins. What do you mean by paraffins? Any idea? Okay, there is a particular meaning for this particular word, that is paraffins means little affinity, which means that most of these alkene compounds are inert in nature, so it will call it as paraffins, right? Little affinity. Right? So now we have to know about the general formula for the alkenes, that is given as CnH2n plus 2, right? Which means that N represents the number of carbon atoms present. So CnH2n plus 2 will be the general formula for the alkene compounds. Now I have a question for you. If I am taking one carbon compound, what will be their formula? Just let me know the answer in the comments. If I am taking a one carbon compound, what will be the particular formula for that first carbon compound? Right. So if I am taking n is equal to 1, right? N is equal to 1, which means that C1, or simply I can say it as C, 2 into 1 plus 2, that is C4, right? 2 plus 2, 4. So this is the first carbon compound containing carbon-carbon single bond, or what will be the name? Hi Vishal. I hope you have studied about the nomenclature of compounds, right? Organic compounds. In your grade 11 chemistry, you will be studying about the nomenclature of compounds. So what will be the name? Yes, Adar, we are correct. Methane, right? You must have an idea about the carbon number and their word root, right? So if you are taking carbon as 1, it will be meth. Word root will be meth. Here it is an alkene group. So suffix will be ANE. So it is methane. What about the next compound? If N is equal to 2, what will be the next compound? Quickly. Okay, there is a request for your side. Yes, ethane, right? So, if you are watching any of the organic chemistry lecture, try to make notes with me, right? So, it will be very helpful. Try to practice questions with me, try to make notes with me. So, it will be very easy for you to understand the organic chemistry concept. Ethane, right? So, N is equal to 2. So, I am taking here C2, 2 into 2, 4 plus 2, 6, right? C2H6. Ethane. What about the next one? N is equal to 3. C3, H8, right? 3 into 2, 6 plus 2, 8. C3, H8, it will be propane. So on, it will become butane, pentane, hexane, heptane, right? Just like that, right? So, if you are looking into the chemical formula or the general formula of the particular alkene, what you are observing? Is there any observation? For example, in the first case I am saying that if I am adding one CH2 molecule, if I am adding one CH2 molecule to the methane, what I will get? I will get ethane molecule, right? Yes, CH2 difference, right? So similarly, if I am taking ethane molecule, I am again adding CH2 molecule, right? So it will form the propane molecule, which means that in this series, in this particular compound, alkenes, I can say that each of the compound is having a CH2 difference. So this particular series is known as homologous series. Clear? So this is the homologous series of the alkenes, in which each of the component or each of the element, each of the molecules or the members having a difference of CH2 molecule, right? Clear? Similarly, you can predict the homologous series for the alkene and alkane also. Is that clear? This is the very basics of the alkanes. Okay, if it is clear, just give me the thumbs up in the comment box so that I can move to the next part. Yes, fine. Now, let us start with the IUPAC nomenclature, right? IUPAC nomenclature of the alkanes or the saturated hydrocarbons. Here I am giving some examples. Try to find out the IUPAC nomenclature or IUPAC nomenclature. The formula is given here. Okay, this will be the expanded structural formula for the first compound, CH3 tries, right? This is our first carbon, CH3 tries, 3 molecules of CH3, then carbon, then CH2, again carbon containing 3 CH3 molecules, right? This will be the expanded structural formula for the particular compound. Now, what you have to do for naming the organic compound? You have to find out the longest chain, right? Yes, you have to find out the longest chain. What will be the longest chain here? So that you are naming the compound. Number in the compound here 1, 2, 3, 4, 5. You can try with the maximum possibilities. If I am trying like this 1, 2, 3, 4, 5. This is a 5 carbon chain, right? Then if I am trying from here 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, right? However, you are calculating or giving the number of the particular compound, you will get that it will be a 5-membered ring, right? 5-membered ring. So we can call this particular compound as a 5-membered ring because it is an alkene group, right? So it will be a pentene, right? Now, is there any branches are present? You need to name the branches also along with their position numbers, right? So this will be our numbering. In the second position, there is 2-methyl group, right? 2-methyl group. Are you able to understand my point? In the second position, there is 2-methyl group. Again, in fourth position also, there is 2-methyl group. So I can call this as 2-2, right? 2-2. Again in 4-4, you need to mention the position of each branches, right? 2-2, 4-4. How many methyl groups are present? If you are containing 1, 2, 3 or 4 methyl groups are present, you should give the suffix like that. Tri, tetra, just like that. Clear? Yes, the name is 2244. tetramethyl pentane, right? Tetramethyl pentane. Yes, Prashant, you are correct. Is that clear for everyone how we are doing the naming of the compound? First, you need to find out the longest chain. You have to try the maximum possibility, find out the longest chain, then give the numbers of the particular longest chain, then give the position for the each branches. Clear? Then what about the name of second compound? Okay, this will be the expanded structural formula for the second compound. So you need to find out the longest chain here. I will try to find out the longest chain here. So I am taking it from here. Okay, what is the longest chain here? What is the longest chain here? It will be the 5 carbon chain, right? By a single look, you may experience that it will be butane chain, but you have to do the maximum possibilities here. So once I am calculating or naming, numbering from here, I will get a 5 carbon chain. So it will be a pentane group, right? It will be a pentane group. So while numbering here, I can say that in the third position, right? In the third carbon, there is having 2 methyl groups, right? So I will written the name as 3,3, 2 methyl group, right? So it will be dimethyl. What will be the longest chain here? It will be the 5 carbon, so pen. Alkene group, suffix will be pentene. So 3,3 dimethyl pentane will be the IUPAC nomenclature of this particular compound. Is that clear? Or is there any other possibilities for the long chain? Yes, 3,3 dimethyl pentane. Yes, correct, Anish. There should not be any spelling mistake, right? 3,3, you have to mention the position. Then after that, there should be a hyphen. This is important, right? After the position number or carbon number, there should be a hyphen. And all the letters should be in the small letters. And there will not be any space between the branch's name as well as the word root, right? Clear? Now let us see, while giving the name of particular compound, how we can draw the structural formula of that particular compound. Right? It will be quite easy, right? This is already, the position of the carbons are given here, branches are also given here, word root is also given here. You have to need to draw the structure, right? So try along with me. This is the first compound, right? What will be the longest chain here in the first compound? How many carbons are present in that particular compound? Heptane, right? Which means that the longest chain must contain 7 carbons. So I will start with the carbon here. 1, 2, 3, 4, 5, 6, 7. Right? Yes. So if I am starting numbering from here, one, 2, 3, 4, 5, 6. So in the third position, right? Third position there will be a CH3 group. Third position there will be a CH3 group. So here will be CH3. In fourth position there will be 2 methyl groups are present. So I will be taken it as CH3. Again in fifth position there is another CH3 group. Now we have to balance the valency of carbon by adding hydrogen, right? Here it will be CH3, CH2, it will be CH, then 4 valencies are completed here. Here it will be CH2, CH2, CH3, right? This will be the structural formula for this particular compound. Is that clear? Now what about the second one? Hexane, right? 6 carbon ring. So I will draw the first 6 carbon. 6, right? This will be the second position. It will be methyl. Then in the 5th position, it will be again methyl, right? CH3. So we have to balance the valencies of carbon by adding hydrogen. Clear? This will be the 2,5-dimethyl hexane. Yes, it is the 5th position, right? So if I am taking the position from here, 1, 2, 3, 4, 5, right? I has already added the methyl group in the 5th position. Atharv, is that clear now? Okay, I got that. In the first question, the valency was incorrect, right? Oh, it was mistake from my side. There will be hydrogen only. Yeah, you are correct. In order to balance the valency of the carbon, it should be hydrogen only, right? So it is already a methyl group is present. Okay, thanks for the correction. Now, this will be taken as a homework question. Try with this question. Try to find out the structural formula for this particular compound. Okay, I hope you have already noted down the question. Now let me move to the next topic, that is the isomerism. Okay, what do you mean by isomerism? Yes, you are correct, Anish. Try to get the complete structure as taken as a homework. So what do you mean by isomerism? Okay, isomerism means it is a type of combination, right? If you are taking any of the two compounds or the two compounds, we can say that it must have the same molecular formula but have difference in their structures or position, right, in functional group or something. So in case of alkenes, we will be discussing about the two types of isomerism. One is structural isomerism and the next one is conformational isomerism. So in the case of structural isomerism, we can say that these are the compounds that is having, isomers are the compounds that is having same molecular formula but have different structures, right? Difference in the structures. Then what about the conformational isomerism? Any idea? Right? In conformational isomerism, we can say that it is a type of stereoisomerism. We can see in detail. So let's start with the structural isomerism. So if I am taking an example of butane, what is the structural formula of butane? These, I hope it was C-host structure, right? C-host structure and Newman projection. It will be the method to represent the conformational isomers. It is not the conformational isomers. Clear? So if I am taking the butane, right, it will be 4 carbon compound having hydrogen. 4 into 8 plus 2, 10, right, C4H10. So the molecular formula will be C4H10. What will be the possible isomerism or isomers for the particular compound, which is already given here. Okay, isomerism is the process or the method in which two or more compounds that is having same molecular formula, right? For example, if I am taking C4H10 here, these two compounds exhibit the same molecular formula of C4H10. For example, here 1, 2, 3, 4. 4 carbon, 3 plus 2, 5 plus 2, 7 plus 3, 10 hydrogen, right? C4H10. Then what about here? Again, 1, 2, 3, 4 carbon, C4. 3 plus 1, 4 plus 3, 7 plus 3, H10, right? So, the particular compound that is having same molecular formula but have their difference in the structure, position or functional group is known as the isomerism in general. Here it is difference in their structure, so it is called as structural isomerism. Clear? So in case of butane, I will be writing the straight chain compound here, right? CH3, CH2, CH2, CH3. This is the normal butane. So it is represented as N-butane. Clear? Now, in the second case, I am taking another challenge here. I just changed the position of methyl group, right? I changed the position of methyl group. For that, you can say that there will be the 4 carbon compound, right? 4 carbon compound. But the difference is that this methyl group is present on the second position, right? Second position. So, I can call this compound as 2-methyl propane. The longest chain will be 1, 2, 3, propane, right? In the second position, there is a methyl group, so it will be 2-methyl propane. That is the IUPAC nomenclature of this particular compound, right? In the common name, we can call this particular compound as isobutane. Okay, what do you mean by iso? Okay, if any of the compound that is containing this part, right? Okay, just like this methyl group, right? If it is contained this part, I can call this as iso compound, right? Iso compound. In general, if I am taking if any of the compound contain this part, if the carbon is connected to 4-methyl group, it will be called as neo compound, right? Neo. Is that clear? So, in this particular compound, 2-methyl propane, you can see that there is a CH3 part, right? CH3 part. Is that clear? Okay, CH3 part is present. So, I can call this compound as the isobutane. This is a common name. Clear? So, this will be the structural isomers of the butane compound C4H10. Then, if I am taking the next one, C5H12, right? Pentane. C5H12 pentane. What will be the isomers? First, I need to draw the straight chain compound, right? CH3, CH2, 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 CH3, which means the normal pentane, right? Represented as N-pentane. Then, for a variety, I am changing the position of methyl group here. I will be keeping the methyl group in the second position of carbon, right? Second position of carbon. So, I can name it as 2-methyl butane, right? Carbon containing 4 chain. 4 carbon chain will be the longest chain here, so it will be butane. 2-methyl butane. So, it is contained in the CCH3 part, right? So, again I can call it as the isopentane. Then, what about the next one? It will be the neo part. It is containing CCH3 tris group, right? So, it will be the neopentane. Otherwise, what will be the name here? 2,2-dimethyl propane, right? 2,2-dimethyl propane will be the IUPAC nomenclature of a neopentane. Clear? Now, try to find out the 5 structural isomers of the hexane compound C6H14. Hi Harshit. Okay, what is your doubt? The previous question. Yes, N-hexane and methyl pentane, right? You should be mention the position of methyl group also while writing the IUPAC nomenclature. Okay, Harshit, I hope you are asking about this platform, right? This is Infinity Learn JEE YouTube channel by Sri Chaitanya. Okay, I will try to decrease the sound of marker, right? Okay, fine. Then what about the fourth isomer here? Fourth isomer. Right? Are you able to understand? These are the 5 different types of isomers of hexane. First one, it is N-hexane, right? N-hexane, which means the straight chain carbon compound of the 6 carbon compound, right? N-hexane. Second one, I am changing the position of methyl group in the second position, right? So it will be 1, 2, 3, 4, 5, right? So it will be the pentane chain having the second methyl, 2 methyl pentane. Now again I am changing here 3 methyl pentane. Then what about here? I was using here 2,3 dimethyl butane, right? 2,3 dimethyl butane. Then it will be the neohexane, right? Neohexane. Clear? So try to find out the maximum possibility of isomers here. You can try with the higher alkanes also. Heptane, octane, just like that, right? Is that clear? How to write the isomers, structural isomers of the alkanes. So now let us talk about the conformational isomerism, right? Conformational isomerism. I have already mentioned that it is a type of stereoisomers, right? It's a type of stereoisomers. So we have already seen that there will be a carbon-hydrogen bond, right? So for example, if I am taking an example of ethane, right? Ethane, CH3, right? This will be our ethane. So this is a single bond, right? So if I am changing the position of these particular, for example, okay, this is our carbon, right? If I am changing the position of these, what to say, to rotate the particular bond, right? So if I am rotating the single bond in between the carbon-carbon compound, I can get the more conformations, right? Again, I can get the different structural, spatial arrangement, right? Are you able to understand? So in words, we can define the conformation as these are the isomers that formed due to the free rotation of C-C single bond. That is, this is our ethane molecule. For example, if I am taking this is the ethane molecule, there will be one carbon, here is also one carbon, right? If I am rotating this particular compound, I can get more isomers, right? Having different spatial arrangement. This type of arrangement is known as conformers or rotamers, right? So while discussing about the conformation isomers of the alkenes, we will get 2 parts. One is eclipsed one, another one is staggered one. So in order to represent the conformational isomers of the alkene, we will take 2 representations. One is Soho's projection, another one is Newman's projection, right? So let us start with the Soho's projection, right? I will be writing the elaborated structural formula of ethene here. Right? This will be our first carbon, this will be the second carbon. It is containing 3 hydrogen atoms. So, I am trying to draw the structure here. If you have any doubt, you can ask. This is our first carbon, this is the second carbon. In the first carbon, there will be 3 hydrogen atoms, right? So, it will be written as H, 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 right? What about the second carbon? Again, it is having this hydrogen atom, right? 3 hydrogen atom. So, hydrogen, hydrogen, right? Clear how to write the Sohor's projection of the conformation isomers of the alkanes. This is the Sohor's projection. This will be the first carbon, this will be the second carbon. If any of the group is attaching to the carbon, it will be represented as the single lines, right? So, now we can define what you mean by the staggered and eclipsed conformation, right? So, I will just explain. If I am considering these hydrogen, right? This is the hydrogen that is present in the case of 2 carbon atoms. I can say that these are very close apart, right? They are very close to each other. And I couldn't understand if it is able to possible without a structure or the model. If you are able to understand, if I am taking these particular hydrogen, I can say that these hydrogens are very close to each other. So, this particular conformation is known as eclipsed conformation. Have you observed about the eclipse, right? Grahan, like that. Eclipse, there will be the overlapping or the overlapping of particular orbits, right? So, this is the eclipsed conformation. One hydrogen is very close to the another hydrogen, right? So, what will be the next possible isomerism here? Okay, I am just keeping the first carbon here. Now, I am trying to rotate this particular second carbon atom, right? I am trying to rotate the second carbon atom around 180 degree. What will happen to the position of hydrogens? These hydrogen, right? The hydrogen in the upward direction will go to the downward direction. So, I will draw from here. This will be our hydrogen and this will be the another one. Right? So, now you can say that these 2 hydrogen, if I am considering these 2 hydrogen, right, they are very close apart, they are very far apart, right, they are very far apart. So, such a conformational isomer is known as staggered conformation. Staggered conformation. Clear? Yes, staggered conformation like trans, right? It's a type of geometrical isomerism. Okay, what is the difference between eclipsed and staggered conformation? In the case of eclipsed conformation, the 2 hydrogen atoms are very close to each other, but in the case of staggered, it will be very far apart, right? Now let us express the conformation isomers in terms of Newman projection, right? It is little bit easy. For example, this is our molecule, right? CH3, ethane. I am representing along with the structure of ethane here. So, according to Newman, this will be our first carbon, right? This will be our first carbon. The second carbon is represented by a circle. Second carbon is represented by a circle. Now, in the first carbon, there will be 3 hydrogen atoms, right? While drawing the structure, you should be noted that all the bond length should be same, right? There will be some mistakes while drawing this picture. Okay, what will be this conformation, whether it is eclipsed or staggered? You can observe any of the hydrogen atoms present in the first and second carbon. Now identify whether it is eclipsed or staggered conformation. If the hydrogen atoms are very close, it will be eclipsed. If it is very far, it will be staggered. Eclipse, right? Yes, other we are correct. So it will be the eclipsed conformation, right? So as compared to the Sohor's projection, it is very easy to understand the conformational isomers using the Newman projection, right? Then what will be the staggered conformation of the ethane by using the Newman projection? This is our first carbon. I am keeping just like that. Now I am rotating the second carbon, right? I am rotating the second carbon. What will happen here? First carbon having hydrogen. So this is our hydrogen, right? This will be our second carbon. Then rotating, right? While rotating, it will form like this. So this is the hydrogen atom present in the first carbon. This is the another hydrogen atom present in the next carbon, right? So now you can observe that these two hydrogen atoms are very far apart, right? Very far apart. So I can call this conformation as the staggered conformation. Clear? So this is the exact representation of staggered and eclipsed conformation using Newman projection, right? So in between these two structures, if I am rotating the second carbon, right, I can get more possibilities, right? More possibilities of isomers. So any of the isomers, any of the conformational isomers that exist between eclipsed and staggered form is known as skew conformation, right? Skew conformation. Is that clear? Now, if I am asking about the stability, which form will be more stable? Which form will be more stable? Whether it is eclipsed or staggered. Okay, Adara, which point I want to repeat? Skew conformation, right? So, we have already seen that there will be two conformations, right? So, first carbon I am keeping like this. Now, I am rotating the now I am rotating the second carbon, right? So while rotating each of the angles, for example, I am taking 60 degree, 120 degree, just like that, I will get more conformations, right? More type of spatial arrangement of atoms there for the hydrogen atom. So I will get the different types of isomers in between eclipsed and staggered conformation, right? Are you getting my point? So the particular isomers that exist between eclipsed and staggered conformation is known as skew conformers, right? No need to worry about the skew conformation. You have to get an idea about the eclipsed and staggered conformation only. Clear? Yes, what about the stability here? For example, if I am taking the eclipsed conformation, right, there will be the two hydrogen atoms are very close apart, there will be maximum repulsion, right? If there is having maximum repulsion, stability will be very less, right? Stability will be very less. So I can say that in stability order, eclipsed is less stable than the staggered, which means staggered is more stable, right? Because in the staggered conformation, the two hydrogen atoms are very far apart, about 180 degree. So I can say that there will be minimum repulsion, that is maximum stability. Clear? Okay, fine. I hope it was clear for everyone. Now let us talk about the method of preparation of alkanes. In the case of hydrocarbons, we will be dealing with the nomenclature, isomerism, and the method of preparation and their chemical properties, right? Physical and chemical properties. So here I will be starting with the method of preparation of alkanes. There will be three methods. First one, it is from the unsaturated hydrocarbons, right? if any of the compound that is containing double bond or multiple bond, double bond or triple bond, right? Such compounds are known as unsaturated hydrocarbons. From the unsaturated hydrocarbons, I can prepare the alkene. This is the first method. Then second one, I can prepare the same alkenes from the alkyl halides, right? Alkyl halides means halogen group is attached to the alkyl group, right? So Rx, X will be any of the halogen. It will be fluorine, chlorine, bromine or iodine, right? Then the third method, it is from the carboxylic acid, RCOOH group, right? So let us start with the first method from the unsaturated hydrocarbons, right? First I will write the reaction here. For example, if I am taking CH3, okay, I will take the simplest one in order to understand. CH2, CH, right? This is the simplest alkene. Ethene, right? CH2, CH2. You need to convert it into CH3, right? CH3, CH3, ethane. What you have to do? Any idea what you are adding here? What you are observing here? Here there will be double bond, right? This one of the double bond is breaking, then hydrogen is adding here, right? So, in order to convert the unsaturated hydrocarbons to the saturated compounds or alkenes, I will be adding hydrogen, right? I will be adding hydrogen. So, here the reagent will be hydrogen. So, I am adding plus hydrogen, right? Plus hydrogen. One of the bond is breaking from here, then two hydrogens are adding here. So, it will form CH3, CH3. Ethene, alkene, right? Alkene. Yes, breaking the bond, then adding the hydrogen. Then, if you are adding hydrogen, there will be the presence of catalyst, right? You will be taking the catalyst as either nickel, platinum or palladium. This is compulsory, right? If you are adding hydrogen, you will get the ethane from the ethene or the alkane from the alkene or alkyne by using the catalyst of nickel, platinum or palladium, right? So, this process is known as the addition of hydrogen, so it is known as hydrogenation, right? So, we can prepare the alkane or the saturated compounds from the hydrogenation of unsaturated hydrocarbons. Is that clear? Okay, number 4 JEE Main second attempt, no, you will try to follow or subscribe with this particular channel, Infinity Learn JEE channel. You will get more classes for the April attempt for physics, chemistry and maths lectures. So this is the first method. I hope it was clear. Now let me move to the next method from the alkyl halides, right? Alkyl halides. So the first method is the reduction, right? I am taking the reduction here. So in case of reduction, right, for example, if I am taking Rx, any of the alkyl halide, what do you mean by reduction? Again, addition of hydrogen, right? Addition of hydrogen. So I will again adding hydrogen here in presence of zinc in acetic acid, zinc in hydrochloric acid or zinc in copper coupled, right? If you are taking any of the reactants here, you will get the product RH, right? In general, these are represented as zinc in H+, which means zinc in the acidic medium. Is that clear? This is the first method of preparation of alkenes from the alkyl halides by the reduction. Again, this is again the addition of hydrogen. We can also call it as the hydrogenation. These reagents are very important. Now let me move to the next method. This is a name reaction. It is very important. Again from the Rx molecule, right? again from the alkyl halide, I am trying to prepare the alkane, right, by using the sodium metal in presence of dry ether. So if you are taking about the Woods reaction, sodium will be the reagent in presence of dry ether, right? So what you are observing here, I am taking 2 molecules of alkyl halide, right? 2 molecules of alkyl halide in presence of sodium in dry ether. What you are observing? An alkane is producing, right? An alkane is producing, which means that in the case of alkyl halide, for example, I am taking here, you will get the ethene, right? So in the reactant there will be only 1 carbon, right? CH3Cl, there will be 1 carbon. In the product it will be 2 carbon, which means double the number of carbon atoms are producing in the case of Woods reaction, right? So what will be the product here according to this method? Okay, you may feel that there will be one product is forming, that is CH3, CH2, CH3, propane, right? But according to this method, we will get 3 products: ethane, propane, butane, right? Ethane, propane, butane are the product of this particular reaction. So in general, if you are discussing about the Woods reaction, we can say that it's a particular method to prepare the alkanes having even number of carbon atoms, right? Alkane having even number of carbon atoms. Okay, I hope it was clear. Now let me move the next method. We have 2 more methods to cover. Okay, this is another named reaction that is known as Franklin reaction, right? The only difference between Woods reaction and Franklin reaction is that here the reagent will be, or the metal used will be zinc, right? If you are taking zinc instead of sodium in dry ether, we will get the same product, right? Even number of carbon atoms containing alkene. That particular reaction is known as Franklin reaction. So in your JEE Main examination point of view, these named reactions are very important. Right. Listen here. If I am taking the methyl chloride, right? Methyl chlorine, right? Methyl chlorine, CH3, and it is producing CH3, right? 2 carbon atoms are producing. So, in this particular reaction, you will get the 3 products. It is based on the Woods reaction mechanism. I will be explaining detail in the next class because it is little bit time consuming. So, if you are taking these compound, one point you have to note that it will double. So, it will form the propane first. So, it will form the ethene first, right? CH3. Then it will form the butane, right? CH3, CH2, CH2, CH3. Then it together combine CH3, CH2, CH3. So 3 products are forming, right? So in this particular reaction, it is very difficult to separate these particular compound, right? Ethane, propane and butane. So we can say that this is the particular method which is used to produce carbon containing even number of alkenes, right? Even number of alkenes. Alkenes containing even number of carbon atoms, right? Okay, I hope it is clear. Now the last method of preparation from the carboxylic acid, right? Carboxylic acid. So first method, it is the decarboxylation, right? This is the sodium salt of carboxylic acid, RCOONA. It is reacting with the soda lime. this combination NaOH plus CO is known as soda lime, right? Soda lime. So what you are observing here, right? It will break like this. Then it will form Na2CO3. Na2CO3 plus RH, right? Na2CO3 plus RH. This is the reaction of the particular compound. Or we can say that here we are trying to eliminate the carbon dioxide, right? Trying to eliminate the carbon dioxide molecule. So this method is known as decarboxylation, right? Decarboxylation. Is that clear? First method, we are trying to heat the sodium salt or potassium salt of carboxylic acid with the soda lime. Soda lime is NaOH and CaO. So it will produce an alkene. The thing is that here it will be two carbon atom, right? For example, if I am taking CH3CONa, right? You will get the product. CH4, right? CH4, which means that by using this particular method, you can prepare the alkene containing one carbon atom less than that present in the reactant. Clear? It will be the two carbon atom, then it will be the one carbon atom, right? If you want to prepare the alkene having less than one carbon atom present in the reactant, we need to use the method of decarboxylation using soda lime. Okay, now let me move to the last method, that is the Cobb's electrolysis method, right? It is an electrochemical method in which same fatty acid, right? Same salt of carboxylic acid is reacting with water in presence of electricity, right? So you will produce alkenes, carbon dioxide, NaOH and hydrogen, right? Alkenes, carbon dioxide, NaOH and hydrogen. So there is a detailed mechanism is present for the Cobb's electrolysis. Let me explain tomorrow's class. So here, what you are observing here, there will be the electrolysis method, right? Two electrons will be present here. First one, it is anode, right? Anode is having negative charge, cathode is having positive charge, right? So in the case of anode, there will be the oxidation happens, which means loss of electrons. So I can say that RR group, right? RR group means alkene group is produced in the cathode and alkene group is present in the anode and the hydrogen gas is present in the cathode, right? So this will be the method of Cobb's electrolysis. Clear? Okay, I think time is over now. We need to explain about the physical and chemical properties of alkenes in detail. So we will be seeing in the next class. I hope it is clear for everyone. I will be coming back with the next class with the physical and chemical properties of alkene along with these particular mechanisms. So don't forget to subscribe our channel, hit the like button and share this particular session to your friends also. Till then, bye bye all of you. Thank you so much.